internally at Tesla in our factory, and just see like how useful is it, because you have to have you got to close the loop on reality to confirm that the robot is in fact useful, yeah, so we're just going to use it to build things, and we're confident we can do that with the hand that we have currently designed, but for sure there'll be hand version 2, version 3, and we may change the architecture quite significantly over time.
Sorry. Hi. The Optimus robot is really impressive. You did a great job. Bipedal robots are really difficult. But what I noticed might be missing from your plan is to acknowledge the utility of the human spirit, and I'm wondering if Optimus will ever get a personality and be able to laugh at our jokes while it folds our clothes.
Yeah, absolutely. I think we want to have really fun versions of Optimus, so that Optimus can both be utilitarian and do tasks, but can also be kind of like a friend and a buddy and hang out with you. And I'm sure people will think of all sorts of creative uses for this robot. You know, the thing, once you have the core intelligence and actuators figured out, then you can actually, you know, put all sorts of costumes, I guess, on the robot. I mean, you can make the robot look. You can skin the robot in many different ways, I'm sure people will find very interesting ways to yeah, versions of Optimus. So.
Thanks for the great presentation. I wanted to know if there was an equivalent to interventions in Optimus. It seems like labeling through moments where humans disagree with what's going on is important, and in a humanoid robot, that might be also a desirable source of information.
Want to say anything?
Yeah, I think we'll have ways to remote operate the robot and intervene when it does something bad, especially when we are training the robot and bringing it up. And hopefully we design it in a way that we can stop the robot from, if it's going to hit something, we can just like hold it and then it'll stop. It won't like crush your hand or something. And those are all intervention data. Yeah, and we can learn a lot from our simulation systems too, where we can check for collisions and supervise that those are bad actions.
Yeah, I mean, so Optimus, we want over time for it to be, an android, the kind of android that you'd seen in sci-fi movies, like Star Trek: The Next Generation, like Data. But obviously, we could program the robot to be less robot-like and more friendly, and it can obviously learn to emulate humans and feel very natural. So as AI in general improves, we can add that to the robot, and it should be obviously able to do simple instructions or even intuit what it is that you want. So you could give it a high-level instruction, and then it can break that down into a series of actions and take those actions.
Hi. Yeah, it's exciting to think that with the Optimus, you will think that you can achieve orders of magnitude of improvement in economic output. That's really exciting. And when Tesla started, the mission was to accelerate the advent of renewable energy or sustainable transport. So with the Optimus, do you still see that mission being the mission statement of Tesla, or is it going to be updated with, mission to accelerate the advent of, I don't know, infinite abundance or limitless economy?
Yeah, I mean, it is not strictly speaking, Optimus is not strictly speaking directly in line with accelerating sustainable energy. To the degree that it is more efficient at getting things done than a person, it does, I guess, help with sustainable energy. But I think the mission effectively does somewhat broaden with the advent of Optimus to I don't know, making the future awesome. So I think you look at Optimus, and I don't know about you, but I'm excited to see what Optimus will become. And, this is like, if you could, you can tell, like any given technology, do you want to see what it's like in a year, 2 years, 3 years, 4 years, 5 years, 10? I'd say for sure. You definitely want to see what's happening with Optimus. Whereas, a bunch of other technologies are, sort of plateaued. Won't name names here, but so I think Optimus is going to be incredible in like 5 years, 10 years, like mind-blowing. And I'm really interested to see that happen, and I hope you are too.
I have a quick question here. I'm Justin, and I was wondering, are you planning to extend conversational capabilities for the robot? And my second follow-up question to that is, what's the end goal? What's the end goal with Optimus?
Yeah, Optimus would definitely have conversational capabilities. You'd be able to talk to it and have a conversation, and it would feel quite natural. So, from an end goal standpoint, I don't know. I think it's going to keep evolving, and I'm not sure where it ends up, but someplace interesting for sure. We always have to be careful about don't go down the Terminator path. That's I thought maybe we should start off with a video of the Terminator starting off with this, skull crushing, but that might be, people might take that too seriously. So, we do want Optimus to be safe, so we are designing in safeguards where you can locally stop the robot, and with basically a localized control ROM that you can't update over the internet, which I think that's quite important, essential, frankly. So, like a localized stop button, remote control, something like that, that cannot be changed. But it's definitely going to be interesting. It won't be boring. So.
Okay, yeah. I see you today. You have very attractive product with Dojo and its applications. So I'm wondering, what's the future for the Dojo platform? Will you provide infrastructure as service like AWS, or you will sell the chip like the NVIDIA? So basically, what's the future? Because I see you use 7 nanometers, so the development cost is easily over $10 million US dollars. How do you make the business business-wise?
Yeah, Dojo is a very big computer, and actually will use a lot of power and needs a lot of cooling. So I think it's probably going to make more sense to have Dojo operate in a Amazon Web Services manner than to try to sell it to someone else. So that would be the most efficient way to operate Dojo, is just have it be a service that you can use that's available online, and where you can train your models way faster and for less money. And as the world transitions to software 2.0,
and that's on the bingo card.
As someone I know has to now drink 5 tequilas. Let's see. Software 2.0
yeah.
will use a lot of neural net training. So, it kind of makes sense that over time, as there's more neural net stuff, people will want to use the fastest, lowest cost neural net training system. So I think there's a lot of opportunity in that direction.
Hi, my name is Ali Jahanian. Thank you for this event. It's very inspirational. My question is, I'm wondering, what is your vision for humanoid robots that understand our emotions, and art and can contribute to our creativity?
Well, I think you're already seeing robots that at least are able to generate very interesting art with like DALL-E and DALL-E 2. And I think we'll start seeing AI that can actually generate even movies that have coherence, like interesting movies and tell jokes. So it's quite remarkable how fast AI is advancing at many companies besides Tesla. We're headed for a very interesting future. And yeah, so you guys want to comment on that?
Yeah, I guess the Optimus robot can come up with physical art, not just digital art. You can ask for some dance moves in text or voice, and then you can produce those in the future. So it's a lot of physical art, not just digital art. Yeah.
Oh, yeah. Computers can absolutely make physical art. Yeah. 100%.
Yeah, like dance,
Sure.
play soccer, or whatever
Yeah.
I mean, it needs to get more agile, but over time, for sure.
Thanks so much for the presentation. For the Tesla Autopilot slides, I noticed that the models that you were using were heavily motivated by language models. And I was wondering what the history of that was and how much of an improvement it gave. I thought that was a really interesting, curious choice to use language models for the lane transitioning.
So there's sort of two aspects for why we transition to language modeling. So the first...
Talk loud and close.
Okay.
It's not coming through very clearly.
Okay, got it. Yeah, so the language models help us in two ways. The first way is that it lets us predict lanes that we couldn't have otherwise. As Ashok mentioned earlier, basically when we predicted lanes in sort of a dense 3D fashion, you can only model certain kinds of lanes, but we want to get those crisscrossing connections inside of intersections. It's just not possible to do that without making it a graph prediction. If you try to do this with dense segmentation, it just doesn't work. Also, the lane prediction is a multimodal problem. Sometimes you just don't have sufficient visual information to know precisely how things look on the other side of the intersection. So you need a method that can generalize and produce coherent predictions. You don't want to be predicting 2 lanes and 3 lanes at the same time. You want to commit to one, and a generative model like these language models provides that.
Hi. Hi. My name is Giovanni. Yeah, thanks for the presentation. It's really nice. I have a question for FSD team. So for the neural networks, how do you test, how do you do unit tests, software unit tests on that? Like, do you have like a bunch, or I don't know, maybe thousands or cases where the neural network that after you train it, you have to pass it before you release it as a product, right? What's your software unit testing strategies for this, basically?
Yeah, glad you asked. There's like a series of tests that we have defined, starting from unit tests for the software itself, but then for the neural network models, we have VIP sets